Hello, I am Jason Swan with DB Services, and today we are going to discuss how to improve storage space by transferring Salesforce files to an external system like Google Drive. To give some context, each file in Salesforce is composed of three objects: a content document, a content version, and a content document link. We'll have to work with all three of these objects to export them to an external system, while still ensuring that everyone has proper access to the file. With that, let's go through the steps of setting up your Salesforce org for external file storage. First and foremost, you have to turn on Files Connect. This is what allows users to access external systems in Salesforce. After that, you can create a permission set with Files Connect Cloud to assign to individual users, or you can enable Files Connect Cloud on a profile if you want multiple users to have access. The next step is to create an authentication provider. The authentication provider is what gives Salesforce the permission to access the external system. Give a name to the authentication provider. The consumer key, consumer secret, and endpoint URLs will all be created in the external system. There are different steps depending on the external system, but thankfully, Salesforce provides instruction articles for common external systems, such as Google Drive or SharePoint. Now that Salesforce is connected to your external system, you have to define how Salesforce accesses the system by creating an external data source. Name your external source and use the authentication provider that was made earlier. There are a couple other settings to choose from, but this is another case where Salesforce provides instruction articles for setting up an external data source with common external systems. After setting up the external data source, run a sync to automatically generate an external object for the next step. The next step is to create an external object so that you can store the external files as records in Salesforce. External objects are built like any other object, except you also have to input the external data source as well as a table name. After creating the external object, you can define fields like with a normal Salesforce object. If you synced the external data source to Salesforce, the object and a couple fields will be generated automatically. Make sure to use or add a field that will store the ID of the content version that an external object will copy, as we can use this to more easily identify which files were copied. You can also create page layouts and buttons for the external object. If everything is done right, you should see the external records appear under the Files tab. You can also create a custom tab if you want to view the external records like any other object. Now that we set up the external object, we need a way to identify which files have been sent to the external system. To do that, we are going to add a new checkbox to the content version object. If this checkbox is checked, we'll know that the file has been copied to the external system. We can also add a field to store the ID of the external object that copied the content version. The next step is to start exporting the Salesforce files to the external system. This can be done with a service like AWS Lambda or Azure Function. The core logic of this function is to export each new content version and then mark these content versions using the Sent to External System checkbox we made in the last step. We will also store the ID of these external records on the content versions they came from. Finally, we also need to store the time that this function runs in our Salesforce org, as this will be useful in the next step where we start replacing the native files with the external files. After the serverless function has copied the files to the external system, it is time to start reconstructing the connections to the old files. This is where the sample code comes in. The sample code has a couple steps to perform to build these connections. First off, the code runs in a batch format since it may be too much of a load on the system to update every file at once. For each batch of content version records, it will query each external record that the content version is related to. After finding these external records, the code will then build new content version records based on the external data and insert them into Salesforce. After doing this, it will take the content document of each content version and then get each content document link attached to the content document. The code then clones these content document links, but replaces the old content document with the new content document that was generated when creating the content version record. After inserting these new content document links, the connections to the external system will have been built. Now that we have a better understanding of the sample code structure, let's see it in action. This case has an image of a dog attached to it that we want to store externally. At this point, the image has already been uploaded to an external source. We just have to build connections to it. Since we don't want to wait for the sample code's scheduled run tonight, let's manually run the sample code in the console. The sample code does not include deleting the old file, so we should see 2 dog images attached to the case. Since the image is being stored externally, we won't be able to view it natively. However, since the attachment is linked directly to the external storage source, we can simply click the link to view the image. At this point, it is safe to delete the old image of the dog. A new batch call at the end of the sample code could be utilized to do this automatically. With that, we have successfully copied our Salesforce files into an external system. Thank you for watching. We hope we helped you save some storage space in your Salesforce org. If you want to learn more, contact us at dbservices.com.